Okay, so I just wanted to do a couple examples of what you would see using, combining the power rule with using ln and log and exponential functions and the natural number. So I've written up here two different functions, and all I want you to do is find the derivative of those. So f of x, ln of x plus 2e raised to the x minus x plus 4. So if I'm looking for the derivative of this, so remember the derivative of ln of x is just 1 over x plus the derivative of e to the x is still e to the x. Remember, when there's a number in front, you're just going to multiply that. So it's going to be 2 times e to the x. So you really just repeat it. And then the derivative of negative x is minus 1. So that's your power rule. And then the derivative of 4 is just a constant, so it's 0. So that's my derivative of the f function. Down here, when I look at it, I see I have an exponential function. So remember, the derivative of an exponential function is the function times ln of whatever your base is. So to find the derivative, the 500 is a constant. It's a multiplier, so I'm going to have to actually keep that in. So times the b to the x, so 0.6 raised to the x power, times ln of 0.6. And that's all. That's all you have to do. You don't have to adjust it any other way. Okay? So what I wanted to do is I wanted to do a couple of those, and then I want to give you an example of where you could actually use these kinds of functions. So many of you own cars, and many of you are talked into buying a new car or maybe a new used car. And so you want to know how much is it going to depreciate. In other words, how much does the value of the car drop every year? So we have an estimated resale value of a company vehicle after T years is given by, so I'm going to do resale value after T years is 20,000 times 0.86 raised to the T power, where T is time in years, okay? So this is the function. This is how much we're going to be able to figure out, all right, what is the car worth after so many years? So what's the rate of depreciation after 1 year? So remember, when we're looking for rate, anything with the term rate in it, rate of increase, rate of decrease, rate of depreciation, you are looking for the derivative. So we have to find the derivative of our resale value. So again, this is our exponential function. So 20,000 is our value that needs to be kept. Then we're going to multiply that by 0.86 to the T power. That's this one right here, times ln of 0.86. Okay? Now, we want to know what's the depreciation rate. Well, here is our rate of depreciation, but we want to know what's the actual value of the car after 1 year. Well, we know what T is now. T is 1. So we can actually calculate this. So we plug it into our calculator, and we can just plug it straight in. So 20,000 times 0.86 raised to the first power, which is still 0.86, times ln of 0.86. And we get negative 2594, and we're going to round it to 2 places. Okay, so again, this is our rate of depreciation. So after 1 year, our car dropped in value by $2,500, right? It decreased in value. Now, if you did this and you got a positive number, right away you would know that you did something wrong, because it's a rate of depreciation. That means you should end up with a negative value. If we wanted to know what's the rate of depreciation after 2 years, you're going to do the exact same thing. You're going to find the derivative, and then you're going to plug in 2. So again, 20,000 times 0.86 raised to the second power times ln of 0.86. and we get a negative 2230.97. So after 2 years, okay, the rate of depreciation starts to slow down. Okay, so now it depreciates $2,230. So now let's look at the rate of depreciation after 3 years. So we have our derivative after 3 years. Okay, so all I'm doing is I'm using the derivative over and over and over again because I'm looking for how much does our value or does our car depreciate. So 20,000 times 0.86 raised to the third power times ln of 0.86, and we get negative 1918.64. Okay, so after 3 years, the rate of depreciation goes down $1,918. Now, if you notice, after 1 year, our rate of depreciation is the highest, right? After 3 years, it's the lowest. So what this means is the longer you have your car, the lower the depreciation rate goes. So it slows down the value of depreciation, okay, the longer you have your car. Oftentimes what happens is people will buy a car, they'll keep it for 2 years, and then they'll trade it back in. Well, you'll never make money buying and selling cars because of that rate of depreciation. Okay, so the longer you have your car, the slower the rate of depreciation is. Okay, that's it.